Good evening, good morning to everyone. From my point of view, the focus of my attention at the moment, and Rich, you would know about this, is the Muon detector, which has been developed by one of our local universities, Swinburne University. And the Muon detector that they've developed is for commercial use. So they're using it so they use the absorption, so they might go underground or underwater, and they're using the difference between the muon flux rate at the surface compared with the muon flux rate down below, whether it's below rock or whether it's below water. And they're using that to basically try and build 3D images of what's going on inside the rock or inside the whatever it is between. Now, associated with that muon detector and the commercial side of things, then they're setting up an educational branch which will be available to schools and to tertiary institutions, universities and TAFEs. And so coming up very shortly, there is a briefing for teachers, which I've put my name down for. That's in about a week's time. They're going to lend us one of the classroom muon detectors, and we're going to run that for a little while. I'll show it to people in my schools that I'm involved with, and on the basis of that, they will fine-tune the educational resources that they're putting out and then make those available to schools in general. The one issue really is that it's not a cheap unit. So that's why I'm looking around for a grant of some sort towards the cost. So that's exploring that with Sarah, and we'll look at other areas as well. Astronomical Society of Victoria might have some interest in acquiring a unit along the way. So that's what's going to take I can give a report back on that coming up. So as I say, I get the briefing in a week's time. I get hold of the unit for a couple of weeks. So by the time we next meet for Drake's Lounge Australia, I should have some information to report back on. So the concept, the underlying concept, is basically cosmic rays coming and hitting the atmosphere, producing muons, muon showers, and the long-term aim is to set up some sort of worldwide network so we can have a look at what's happening with the cosmic ray flux as represented by muons arriving at the Earth's surface. There is some relativity associated with this because the muons that are generated on Earth in laboratories are short-lived. Well, all muons are short-lived. And in theory, if they're produced at the upper layers of the atmosphere, they should not reach the Earth's surface because it's too great a distance. They should have decayed by then, but they haven't. The reason that they haven't is that they're traveling at very high speeds, relativistic speeds, and so their clock goes more slowly than our clock through special relativity. And so they last, from our point of view, they last longer than they would do if they're produced on Earth. And this is part of the senior physics course that's certainly within Victoria. It's probably the same in other states. So to get first-hand experience of muon counts and so on is going to be quite significant for teachers. So early days yet, but I'll have more to report back in our next Drake's Lounge Australia. So that's been occupying me for a little while. That's all I have to report, but I'd like to pass it on to Phil Costigan first, if you're ready, Phil, to give us an
Yeah.
update on the dish. As I say, I've lost track of where we're up to on that. I know the dish is close to operational, and I know that our Northern Hemisphere friends are looking forward to getting some Southern Hemisphere data from it. So, Phil, away you go.
So it is exciting times at the moment. Last weekend, or was it the weekend before? Time goes so quick these days. Last weekend, I think it was, we actually got the dish to work and operate. We were able to receive some radio signal onto a software-defined radio and drive it. I could probably share a little bit just to show people who don't know what we're talking about. Hopefully this doesn't cause any issues. Can you all see that?
Yep, great
Yeah,
picture.
so this is our 8.5 meter dish that we have in our site in Heathcote, Victoria, which is pretty much dead center of Victoria. The dish I'm showing you here is actually the original design and build. And can you see my mouse?
Yep,
Yeah, so at the
yep,
back here is a lead screw that lifts and lowers the dish. And you might notice that that lead screw has not got a cover on it. So what had happened was the lead screw mechanism where the nut is that turns around and lifts and drops it destroyed itself because it was made out of phosphor bronze. All the grease that's on this lead screw gathered dust, turning the grease into a grinding paste. It broke and we did a refurbish. Whilst we did the refurbish, which modified the receivers and the software, the whole thing got a makeover. Where's the thing? So I'll stop sharing that for a second and I'll just bring up this picture. Share. That one? No, that one. Okay, so this is it being now fixed and we have cover over the top of the lead screw and we've replaced the phosphor bronze nut in the middle there. The radio's been changed, everything, and now we hope that it should last more than at least 4 years. So we're looking forward now to doing preliminary tests and calibrations, collimations, and all the other things necessary for us to achieve what we want to achieve, which is to do some mapping of the sky and surveys and all sorts of things, and collaborating with our friends in New South Wales at the Parkes Telescope, where they'd like us to do some preliminary work so that we can give them raw data, and from that raw data they can prepare their equipment without having to do that preliminary work, booking the big 60-meter dish or 64-meter dish or whatever it is. So yes, we've come a long way, and we're quite excited about getting this going. It's not going to happen in the next week or two. It'll probably be a couple of months, maybe 3 months before we're happy with what we've got. But all the mechanisms are in place and working. So great times. So that's my report. Thank you.
yeah, thanks, Phil. It's been a long journey. I think probably longer than you anticipated.
Oh, absolutely. It's
Yeah,
probably been 2.5 years since
yeah,
it failed to getting it to this point.
yeah. But I think it's well worth the effort. It's been quite a team effort as well. I think you've got a great team there.
Absolutely.
Yeah, who with lots of different skills. I think that's the way that it's all come together. So many people with different skills all contributing. So we look forward to yeah, the next stage, Phil, and seeing some data coming out. So good work. I think there's a lot going on at Heathcote. If any of our American friends happen to find themselves in Australia and particularly in Melbourne, let us know and we can easily arrange a visit to Heathcote
Uh,
and have a look around.
Paul, I just noticed Tim Davis has just come online. He's the chap who's put together the software to drive the dish and record the data and have the recording tell us where the dish is pointing at the same time as what the radio is receiving. So he might have a couple of little things he'd like to add to this.
Yeah, thanks, Phil. Yeah, hi, Tim.
Hi, guys.
Phil,
sorry I came in a bit late. Yep.
Yeah, that's all right. Phil's just given us an overview of the mechanical side of things. You might just want to give us a quick run through on your aspect from the software side.
So the idea was, I mean, with the old system, it was all, everything was essentially run by hand. You had to drive the telescope separately from collecting data, and then the data was only presented on a graph on a monitor, which you then had to copy down onto a piece of paper, which is not a great way for collecting data. So we decided we'd move towards trying to automate everything, and part of that was to use the software-defined radio, which we've now got running. And so the whole idea was to then have a computer that would use the software-defined radio to pull the radio data off and to do some processing. And at the same time, that software could then connect to the dish controller that Phil and people have built to drive the dish. So the way it's set up, so my background, I used to work for CSIRO, which is a government scientific research organisation in Australia. And basically I'm lazy. So if I'm doing an experiment, I like to make it automatic, and I just hit the button and then off it goes. There's a couple of reasons for that. The first one is the laziness part. The other one is that you take out, to some extent, human bias. So, if you're looking at a noisy signal on a graph that's moving up and down a little bit, what point do you take it? Whereas if you essentially program up a machine to look for the average and then pull that out, you take out a bit of bias. So that's sort of been the philosophy. So anyway, so the software is currently set up. It's written in two parts. It's done under Linux, and the only Linux machine, I did have an old Mac laptop which was running Linux in it, but that finally crashed. So I moved over to a Raspberry Pi just as a thing to do the development on. And the software-defined radio we're using is an SDR Play device, and they provide it's essentially code that runs in the background that interfaces with the radio, and they give you library functions that you can use to access that. I think that's using a number of different threads, and the graphics display software that I was using, called GTK, to try and get some nice graphics, wasn't thread safe, and so the whole thing was sort of crash, or would randomly crash from time to time. So the concept was to divide the software up into two parts. One is essentially a console-based thing. So in principle, you can log in to the Linux box remotely and just run commands from a console, very simple commands. But if you're actually on the computer, you can also then get up a user display, so that you can then, a graphical user display, which makes it much easier. So I've put in a star chart into that, and then various functions for controlling the radio, and also a number of functions for then collecting data. So one of them, which we were testing out, I was up with Phil a couple of weeks ago, is essentially a grid button, so that it'll draw a grid on the star chart, and you set up where you want that to be and the size, then you hit a go button. And the idea is the telescope will go to each grid point, collect a sample, save the data to a file, and then move on. And that seemed to work quite well, actually. So that's where we are at the moment. What needs to be done next is we need to just check that we want to calibrate the software-defined radio to make sure that we can convert the signals we're measuring into an actual power number, so that we got some quantification of the signals. The other thing is we just want to check the reliability of the whole system in terms of, I know some of the components are temperature sensitive, so the gain and the offsets will vary a little with temperature. And we need to ascertain exactly what those variations are so that we can maintain calibration. So that's essentially where we are at the moment.
Excellent, thank you, Tim. And that emphasises what I was saying about the team that is working on the dish. It's a talented team, lots of different people with lots of different skills, and that's the way the whole thing has been developing. That's everyone's contributing in a different way. So yeah, we look forward to the next stage in that. Joe McGee, I think you've been part of the dish development as well. Have you got anything to add to what's already been said?
No, good morning, everyone, or good afternoon, whatever time it is in States. I'm afraid I've been one of the absent ones. I haven't been involved for a number of months in any way, shape, or form, really. I've been off doing other stuff, so I haven't been involved anywhere near as much as I should be in the dish. I certainly hope to change that over the next few months, but no, unfortunately, I've got nothing to report at this stage.
Okay. All right, thank you. Well, we'll perhaps hear from you next time. I know I've been the same. I've been away and doing other things, so you can't do everything. You just have to try and do what you can at the time. All right, so that's all developing well. We'll hear some more about that as we go along. I can see Duncan there in South Australia. Duncan, have you got anything to report from your end?
I don't think your microphone's working,
Yeah,
Duncan.
that's better. Yep. Okay. You were there a moment ago and then you disappeared. All right, we'll move on and I'll come back to Duncan in a moment when he's got his microphone working. I can see Roger Heap there. Roger, have you got anything to report at this stage?
I think I'm a bit the same as everyone else at the moment. Just a bit busy. I think I said a couple of meetings ago we had a rental house that burnt down. Well, we're in the middle of it at the moment. Got half the roof on, starting to build it all. So yeah, I just don't have time at the moment. So I'm hoping in a couple of months' time that'll all come good. I do have a lot of catching up to do. I've got a lot of little bits and pieces sitting in my shed that aren't connected up at the moment. So that's my plan, is to get my act together, get all those things happening and take it from there. But yeah, really finding your project with the dish interesting, and good to know that there are people around with the sort of expertise that you've got. We may be calling on you at some stage.
Yes,
So
it's
yeah,
a very,
sorry about that. But
very
anyway,
talented
the
team.
meetings are great.
Yep.
It's keeping my interest up. So that's important at the moment, because I've got a lot of other things that are taking my interest from me. So okay,
Yes.
that's it. Thank you.
Very good. Thank you, Roger. It's interesting how life gets in the way of radio astronomy sometimes, isn't it? So, Duncan, are you with us now? Are you operating? Possibly not. No, still not. All right, we'll move on to Rob Lucas. Are you in the States or in Australia?
Hello, everybody. Can you hear me?
Yep, certainly can.
We've just returned from SEC 2025 in Leuven, Belgium, and Paris. And for my report, what I did was I have my scope in a box, and it was running before I went on the trip. And I also have an Alex Pettit antenna, and with the same type of setup. And finally got some data and did the 3D plotting of it, and it seems really good. I'd share my screen, but I don't trust what's happening today. So in radio astronomy, basically, both of the antennas are working and getting ready to move them out to Waruna, the dark sky site. The other thing was a quick summary of the Solar Eclipse Conference in Belgium. Basically, what happened was, Terry Cuttle from Queensland gave a presentation about how to come and see the 2028, total eclipse here in Australia. And Snevar from Iceland, he was a guide that we had for a partial eclipse in Reykjavik, Iceland. He gave a presentation on where to go in Iceland. And then there was another presentation on Spain, where to go in Spain for the total eclipse next year. Jay Anderson gave a good talk about metrology and what to expect in these on these eclipses. There were two presentations on doing flash spectrum analysis of total eclipses, and one of them was for measuring the solar disk radius at different wavelengths, and basically came back and and have started work on the observatory, and I have have the weather station up and running, almost ready to move that out to Varuna, and basically busy, busy, busy. Any questions?
Sounds like you have plenty on, Rob. How many eclipses have you seen now?
Two, not enough. Probably close to 40 something now.
Yeah, amazing. Yeah, you do a lot of running around the world.
And in September, we expect to go to Invercargill, New Zealand for a partial eclipse. We've been
Yes.
there before. And the one time at Invercargill, we were in this 5-story building, and one of us wanted to open the window to take a picture of the partial eclipse. And anyway, Jay opened the window, and all the paperwork in the office, because of the wind, just went everywhere. And we were going to go to the beach at Invercargill, and we headed towards the beach, and we got about a kilometer from the beach, and the water from the waves being blown up the road was about a kilometer away. It just, no way we were going to get to the beach.
Yes. Yeah.
Yep.
Well, I mean, if you look south from Invercargill, I think it's Antarctica next. There's not much else in there.
February for Antarctica.
Yeah.
We're
Yes.
working on that one also.
Yes.
But the good thing about Invercargill is the tuataras, the lizards that have been resurrected, and population increase, and the fastest Indian.
Very good. Yes.
The museum's there.
Hey, Robert,
Yes.
I got a quick question.
Yep.
On your hydrogen measurements, and can you see the large and small Magellanic clouds on the southern hemisphere?
What we found, Alex and I found that they had a lot of RFI interference, and I should be able to get them, but the trees, the neighbors' trees have grown so large, I think they interfere with it. So anyway, the goal is to move it out to the observatory at the dark side.
Okay.
So is there some interest in the large and small Magellanic clouds?
Well, I don't know if they are hydrogen producers or not, but they're one of the major structures that we can't see up here in the north, and I just don't know.
Yes.
I have no idea if they can see them in hydrogen or not. And you're also using Ezra, right? As one of your.
I do both.
And that we're really interested in. Anybody can use Ezra to fill in the southern hemisphere would be great, because right now we got tons of data in the northern hemisphere to fill in the full northern, but we don't have very much at all in the southern hemisphere. So and Robert, I guess, is one of the few. But if we ever get your 8-meter dish, and if you get hooked to Ezra onto that thing, which you should be able to very easily with the software and an SDR, then you get really fine data with that, and add to our database.
Yep, I keep sending emails out to Roger and the gang trying to get some support for this, but as you just heard, Roger is busy, busy, busy taking care of a whole bunch of things. So, so I sit at the house out at Varuna, and I look at the dish and I go, next.
Yeah.
Yeah.
All right.
Are you going to be there next month, Rob? Sorry.
I'll be there every month. Every
You're gonna
month
be
I'm
there
in
next month?
Australia. Yes.
Okay. I'll try and make an effort to get there.
I understand that you're busy. I would have gone to the Eastern So Russell, I would have gone to the Eastern Conference, okay, but the SEC 2025, I started planning for that, last November, a friend of mine, Charles Foucault, who's a NASA educator, and I were supposed to give a presentation at the conference, but he had to back out at the last minute. His doctor said he shouldn't go. So I needed a larger window of advance notice for for conferences.
Okay. Next June is the next conference, and the next Eastern Conference. And then obviously
Okay.
next March is the next Western Conference. Is that good
Any
enough?
idea? I need an exact date to book the flights. That's okay.
Yeah. One other thing, since you're running all over the world for these eclipses, we were able to catch using SuperSyd the eclipses, because it looks like a sunrise sunset to the SuperSyd, and you can actually catch the eclipse as it happens on SuperSyd, which would be very, very fun at these conferences to present that you actually captured eclipse in radio astronomy with this. So just a thought.
Yes. Now I do have the pictures from the Helsinki, Finland radio telescope of a partial eclipse that we went to, there a couple of years ago. So that's why I'm building mine.
Okay. All right.
And
all right. I questioned him enough there, Paul. It's all yours.
I'm just looking for, you mentioned large Magellanic, small Magellanic. I'm just looking for some of my pictures, optical, of those bodies. I'm just getting them ready. I'll show them in a moment. But Duncan, are you back on track now? Still, no, it's still not working, not behaving. You might have to do it in sign language. I think, is that everyone from the Australian end? I think we've covered everyone. I'm just going to put this picture up. I'll share this. If I can. I've only got one screen going at the moment, so it's a bit hard to do it. Share. Well, I struck it. It's saying share, but it's, oh, here we go. Yeah. Okay, can you see that?
Yes.
The Milky Way. So here are the two clouds, large Magellanic, if you can see my mouse, small Magellanic down here. So quite low at this time of year. This was taken in about, around about Easter. So what was that, April? So the clouds are quite low. Up here you'll see the Southern Cross, and the pointers are over here. Southern Cross, Alpha, Beta, Gamma, Delta, Epsilon, you can see. And this is, I don't know whether you can see my mouse, but this is the coal sack tucked in. So top middle on that picture, Southern Cross, and then the coal sack tucked right in there. And would you believe that photograph was taken on an iPhone, which is pretty amazing. And then this one, I think I'm still sharing. Oh no, it's the same one. Try this one. So here's, can we all see that one? It's a different view of the Milky Way. And this is the dark emu. So that we're going back to the Aboriginal culture, you can see again Southern Cross and pointers, but the dark spaces in the Milky Way optically are what are important to the Indigenous cultures, particularly in Australia, but in other Indigenous cultures around the world. They tend to go for the dark spaces. And that's the rising emu. At that time of year, the emu is rising. And at bottom right, you can see again the large Magellanic Cloud. Small Magellanic Cloud is hidden behind the tree. Again, that photograph was on an iPhone. So if you just, I've got a clamp for the phone, tripod, clamp the phone, and because it's dark, I was looking south from the New South Wales coast, looking at basically, well, not south, looking east, so looking straight out to sea, very clear sky, and the iPhone will go up to 30 seconds if it needs to get that exposure. So great place to get optical and then match it up ideally with the radio image as well, if possible. So I think, Rich, I think that's it from the Australian end. We can't hear from Duncan because his microphone's not behaving. We've had, I think, everybody else.
I'll give it a go.
So,
Okay.
oh,
Oh,
there
there he
you
is.
go. He is there.
I
Keep
got
talking
there.
quickly. Yep, talk quickly.
Yeah. What I was going to say, I've been working on a long-term project to build dipole antenna out of PC boards. I've done this before professionally, but this one I'm trying to build out of to go to 21 centimeters. Most of the stuff I've built before was sub-gigahertz. And I'm going to, if I can share my screen, maybe I shouldn't have said that. I'm going to share my screen. You can see some of the initial work. I haven't got a picture here today, but here's it. It hasn't shared. Oh,
No,
never
yeah,
mind.
no.
Um,
Green button down the
so
bottom.
yeah, I've pushed the button down the bottom and
Mm.
it's just not behaving. Yeah, so been working on that. A fair bit of my time's taken on a university project. I'm working with a number of volunteers with University of Canberra to rehabilitate a 10-meter dish, which has had a checkered life. And that's, yeah, an interesting little project. It was, so that's what I've been working on and working with University of Tasmania. So we have similar systems. There will be some difference, but they're rehabilitating a 14-meter. So yeah, there's a bit of work going on there, and there are links into educational stuff, obviously from the University of Canberra point of view, and for outreach to school kids. And another friend of mine, Dave Jauncey, is a professional radio astronomer, and I are working on towards, and I think this will be towards a Gavitt-like approach to using the telescope in the future. This has fortunately got some private benefactor backing, so we have some money to rehabilitate this machine. Otherwise, yeah, I've continued to observe Vela, nothing really to the Vela pulsar, nothing really to report there, other than my timing data is getting adversely affected by an increasing amount of radio frequency interference around in the 900 megahertz band, which was up to about 6 months ago relatively clean. So I'm beginning to see timing degradation and introduction of timing noise into the timing of Vela pulsar. So it will be, I guess, in the near future, will be a search for another 8 megahertz slot in the spectrum to go and get some data, which is getting more and more difficult, I'm afraid. As to the LMC and SMC, yeah, you should be able with that dish to get somewhere on 21 centimeters to see that there is emission from those galaxies. And just a note, there is actually, and you probably won't have the sensitivity because you need something like Parkes to detect it, but there is a what they call the Magellanic stream, and that's a bunch of hydrogen that is actually being cannibalized by our galaxy, stripped out of the LMC and SMC, and flows in towards our galaxy. A bloke, I think it was Professor Mathewson, discovered, and a group discovered this many years ago with Parkes. And yeah, so those two galaxies are in orbit around us, and we're cannibalizing them. I think that's about all.
Excellent. Sounds like you've got plenty on, Duncan.
Hey, Duncan,
A little bit.
quick question about those streams. Are they right in line with the small and the large clouds? Or are they? I mean, do they?
I think they're not directly in line of sight. I think they're in a sweeping arc. But if you, I'm afraid I'm not a hydrogen H1 observer, so I can't make much comment about it. But my memory is actually it streams out of the galaxy, and it's not directly heading for us. It's out of the two galaxies. It's flowing around. So there should be a tail, but I think you'll be pushing it to see it.
Okay, thanks.
Yeah. To get more information, I recommend you search on ANU or CSIRO, Australian National University or CSIRO database about the Magellanic streams, and make a more informed decision about whether you're likely to see it or not.
If you're interested, I can show you a picture that you can. I found this on the web a few days ago. If you want to have a look at it, see if I can show
Yeah,
Far away too.
you show it now?
Yeah, just
far
show it
away.
now. So what I think what they're talking about is, you see, this is the Milky Way galaxy, and this stuff in pink is part of the streaming, and just to the sort of middle right and lower down, you can see two white spots, which are the large and small Magellanic clouds, and then the pink stuff is the streaming. Can I move that? There we go.
Yeah.
Yeah, I suspect it's too weak for us to pick up.
Is that in hydrogen?
Yeah, good question.
It says combined radio and visible. Combined radio and visible, it says on the text.
Yeah, well, that'll so the red will be the radio, but the visible will be the actual background.
Yeah.
Anyway, yeah. So if you do a quick search, you'll find it. Looks quite interesting.
All right, good stuff.
Excellent. Well done all around, all the Australians. I think that's it from this end. Rich, back to you for around your colleague.
I'm just going to go down the list. First, Helen, who's a little under the influence of scorpion venom right now, but Helen, just say hi.
Not available.
Oh, she was on before this, and she was telling me there she is.
Okay, yeah, my cursor's not behaving properly. I'm just sitting here fascinated. I would love to go down to the southern hemisphere and witness all the clouds and all. So hopefully one day I'll get there.
Yeah.
And as I was saying, she explained that it was just a small scorpion, not a big one.
Yeah, they're pretty rampant around here this time of year. But not every year. They kind of come in cycles.
So you Australians don't have all the bad creatures. We got some of them.
Well, they have all the snakes.
Yeah, we've got most of them.
Okay.
We've got Rich. We've got lots of things in the sky that you don't get to see. So yeah, if people want to come over, we can help with pointing them in the right direction.
All right. Did we get Bruce already? Bruce Rout?
Oh, hi. Thank you, Rich. Yeah.
Oh, sorry.
It's okay. Can you hear me?
Yes.
Yep.
Okay. Yeah. I used to teach high school at a place called Tawananui in the middle of the North Island of New Zealand, and seeing the southern hemisphere is spectacular. Particularly the center of the galaxy is amazing. It's an amazing site with the Magellanic clouds and so forth. It's yeah, it's quite an incredible site. I've sort of moving ahead on this interferometer I'm putting, which is in the middle of a goat farm. So I'm calling it the Goat Farm Radio Observatory, and a lot of goats around. And I'm getting a shack put together. Now is about 10 foot by 8 feet. That's going to house all the computers and stuff like that. And I'm putting a Beagle cluster in there. And I'm trying to grab as many computers that are being thrown out so I can cluster it. But I've got an old USRP1 that both Marcus and ChatGPT said, please throw it out. There's no software for it. I did actually find software that can actually read it from New Radio, but all it does is just reads it and spits out raw data, and that's all I needed. So I'm building a pipeline, and right now what I'm doing is putting together just absolute raw software, like how to start with nothing and building it up from first principles and so forth. So I can basically combine the signal from both feed horns. I can do an FFT on it and a power structure and stuff like that. So I've got that kind of ready to go, and I'll just start building up software as I go. I'm hoping to build up something to show people like how the mathematics actually works and how the software actually works from raw principles if you don't happen to have any software at all. I did get a seminar from British Astronomical Association, software working, which was beautiful software. It's great, but I need to get more because I need to get the actual data coming down. And this way, you know, when you get the raw data coming in, I have to write my own code to be able to read it and be able to put it into a form that I can actually, you know, decipher it and analyze it later on. So, you know, it's an interesting project. So that's sort of what I've been doing. I can show you the feed horn. Have you? I don't know if people have seen what this feed horn actually looks like. It's called the Horn of Plenty. If I can share the screen. There's this one. There. That's Paul standing beside it. And what I've done, I made a modification. I've gone down every 5 1/4 centimeters. This is where I put the rivets. So I put the rivets in at a quarter wave all the way down, and it's quite good at picking things up. I've got 2 of these things, and I've managed to be able to pick up galaxies in the Virgo cluster. That was about, oh Lord, almost 10 years ago, where I was working with that, maybe about 8 years ago. I was on the Sixiga Reserve, and there's no radio interference. There's not even any very little cell phone coverage and so forth there. So I'm in quite a radio quiet area. I just want to take advantage of it and try and stay away from the trees. The only thing that's going to sneak up on me are trees. Okay, thank you.
Excellent. Okay, Johnny Cox.
Hey there, can you hear me?
Yes.
Thank you for the opportunity to speak for just briefly. I really enjoyed the Eastern meeting. That was fun. I took my dual dipole and Jim Sky's calibrator, and that all worked beautifully. I was actually able to set up my computer and receiver in Drake's Lounge, and we ran the cable out the window down to the antenna. So that was a historic place to be sitting and running my little bit of my antenna. I mean my computer and such. Was interesting. We had a Jupiter emission. I somehow managed not to get it recorded on my computer, but others did. Jupiter emission and solar emissions pretty much close to the same time. That was kind of unexpected kind of deal, but we had a great time. And that's all I have.
Great. Any questions for Johnny? All right, Adrian.
Yes, hi. Just sitting in, listening in, and trying to pick up as much as I can from all the expertise on the meetings here. I guess I'm relatively new for the radio astronomy group, and so I'm trying to piece together a system, uh, mostly based on the work that was done by one of the BAA radio astronomers over there, a modification of what he calls a solar cooker dish. So I'm trying to get, I've got one of those, and so I'm trying to get that set up, uh, kind of trying to get the parts for it, and working on the feed for it, trying to come up with a Cantena feed that'll fit on that as a modified system for substituting what was originally set up to hold a cooking pot for boiling water or something, making soup. Anyway, that's kind of what I'm working on, and I did sit in on the Eastern Conference on the Zoom remotes, and that was very interesting. Also, the Western Conference, and so both of those were very educational, and got a lot of information out of all those presentations that were excellent. So that's kind of me. I'm out here on the U.S. West Coast in San Diego, California, and unfortunately, I'm very close to a military base, the pretty famous Miramar Air Base. That was the kind of the shooting locations for the first Tom Cruise uh, movie, and so unfortunately, I've kind of done a sort of very basic, just use a kind of a simple directional antenna on 21 centimeters and an SDR radio, uh, an SDR play, try to scan to see what kind of the radio environment is like, and kind of disappointing. The RFI out here seems to kind of point towards the direction of the airbase. I'm just like about a couple of miles from it, and lots of RFI coming from that direction. So I'm not sure if I'll have a lot of success in being able to do much on the 21 centimeter band. But anyway, we'll try. And yeah, I get a lot of passes from the air traffic, a lot of the fighter jets and so forth come over, and I've had a an old TDRO dish that I used to watch Sat TV on the C band, and many a time the the flight path would run right between the Sat and and my antenna, and it would get all kinds of interesting interference whenever one of these unintended military intercepts was taking place. That was kind of a interesting sort of interruption to my TV viewing back when. But in any case, I might also try to convert that dish. It's a little bit bigger than the solar cooker. It's an 8-foot dish, and so that's a little bit larger than the solar cooker. But it's sitting on a pole. The backyard's still there. Had a little bit of warpage from a windstorm at one time. Not horrible, but probably just enough to distort it a little bit. But it still picked up sats even after that, so I guess it's not too horrible. But if I wanted to use it, I'd have to modify the feed. It does have kind of a azimuth sort of control. It has a horizon to horizon motor that you could drive across the Clark Bell, but not a very good elevation type of control. You have to get up there and loosen bolts, and so that'd be kind of difficult to use for different elevation angles for 21 centimeters. So that's why I was trying to utilize the solar cooker, which would be a smaller dish and just kind of more ground based, and maybe you'd be able to manipulate that a little bit better. But anyway, that's the sort of things I'm working on, and kind of spent the last week wearing my other hat, which is I'm actually a molecular biologist, and there was a week-long meeting here at the Salk Institute. I'm sure you've all heard of Jonas Salk, the developer of the vaccine for polio, and I used to work there actually, doing some research in viruses, and there was a meeting on what's called the cell cycle uh, cascades. So that's what I was doing the last week, doing the other stuff that I'm interested in besides radio astronomy. Kind of a strange combination, but anyway, that's kind of where I'm at, and just sitting here listening in to this very interesting conversations. As many have said, I've never been to the Southern Hemisphere, but boy, that would be a wonderful experience. Always wanted to see the small and large Magellanic clouds. It seems like that'd be a real thrill. So maybe someday I'll get a chance to head down there. But anyway, great meeting. So that's it. I'll pass it along to the next person.
Thanks, Adrian. And I lived in Miramar for 2 years after I retired from the Navy. So nice place. Okay, Nils. N1LS. There you go.
Do you hear me now?
Yep.
Okay, great. I'm sorry. I have nothing technically, but I must concur with those guys in Australia are fantastic. Years ago, I spent many years in Meekatharra and Mount Isa and Alice Springs, and the skies were fantastic. However, these were well before my days with optical and radio astronomy, so I had no idea what I was looking at. But it is fantastic. So I think everybody should at least have one chance to go down and see the sun in the skies. Anyway, thank you very much for the presentation. I enjoyed it very much.
Thanks. Preston. Can't hear you. Are you talking? Preston? No, we can't hear you. Hi. See, we just can't hear you. All right, we'll come back. Let's see. I've got this MAWIN.
Hi.
Muon.
Hi. Can you hear me?
Yes.
Yeah. Hi. Yeah. MAWIN. It's Mark Winter.
Okay.
I just joined Sarah a couple of weeks ago. I'm fairly new to all this stuff. I've just recently retired, and I bought the Noelec mesh antenna. This 1 meter by 60 centimeters. I've been following Wolfgang Herrmann, and he was promoting beginners should start with something like H1 observation because you can get some degree of success. I can just share my screen, show you my embarrassing setup. Which screen are you seeing?
Nothing yet. Go to share screen on the bottom.
Yeah, I pressed that.
And then
how do you choose? I don't want screen 1, I want screen 2. Okay, I've got it. Can you see it?
Not yet.
no, oh, there you go.
It's getting there.
Yeah. So yeah, that's my setup. I live in the UK near a sort of medium-sized city, Stockport. We're very close to Manchester. We've got quite a lot of radio interference here. Yeah, so my dish, I must apologize, it's set up on a bicycle stand. So I've got this the no noise amp with this smart T connection with the LMR 400 cable going to the Noelec NS SDR, and I've been recording the signal on my very old ThinkPad. I've been struggling to I've been trying to understand how to use Ezra. I did get some results. I won't play this, but I did record it for 24 hours. Apologies, it's a bit small, this picture, but I can't quite understand what I'm looking at. I think this little hump here, can you see my cursor?
Yep.
I think that little hump there is that the hydrogen line?
Yes.
Yeah. and I tried checking it without the antenna connected. So that's with antenna and that's without, and this looks like a hell of a lot of noise to me. Is this a normal chart you'd get from the what do you call it, with the antenna disconnected? So that's all the noise generated by the LNA.
It
Does that
may
make sense?
possibly be cell phone data. There's cell phone signals in around that area, so it might be cell phones.
Right. Because like I said, I'm in a suburban location outside a big city, and I'm surrounded by noise everywhere. It's a very small back garden I've got. As you can see, I've got a greenhouse on the right and sheds and walls. I just did this drift scan for a little bit of introduction to the whole scheme of radio astronomy.
I think you'll find that almost everybody has a unique background of RFI.
Yeah.
And just by recording it, you can then compare it against like tomorrow's data and stuff and see if it's normal background.
I process the data with what's it called? Easy Collector. I haven't ran any other Ezra routines on the data because, to be honest, I don't know what I'm doing. Like I said, it's all a bit new to me. In fact, it's
show
very
this
new.
on the next one. We'll get the guys to help you and get on the forum. Show this,
Yeah.
and they'll help you walk through this stuff. And you probably got enough data to show some spiral arms or stuff. You just got to run through the processes.
I know this thing does its little tricks for 24 hours. But like I said, I don't know what I'm looking at. Can you see the small yellow circle?
Yep.
That's supposed to be the beam width of this this antenna. It's not true actually. It's about twice as big as that. I think that was 15 degrees, but I think the true beam width is probably 30 degrees for such a small dish.
That's about right.
Yeah.
I'd say that you need to look at activity like lunchtime, evenings, and things like that, to see how the how the usage goes up and down, because you've got clear sky at some stages.
Yeah. Is that little bump there, the hydrogen? It's gone. So I finished the observation.
It looks like broadband interference. You have that flicker, which seems to be across the band.
Right. Anyhow, ladies and gents, that's all I've got to show at the moment. Sorry, not much progress really.
Oh, I disagree. Compared to when I started, I was showing stuff that was all interference, and I thought I was picking up pulsars. That's how bad I was. So you're doing great.
I'm going to have a talk. I've got a meeting tomorrow with Andrew Thornett. He's going to sort of give me some
great
pointers on this.
Great. He's an expert on Ezra.
Yeah.
He'll get you jump started.
Okay.
Take a trip to Scotland or something for a week and try it up there.
Yeah. Sure.
See the differences.
Okay. Well, thanks, Mark.
Oh, sure. Oh, sorry. I had my video off. Oh, no. Here I am.
Not a problem.
All right, guys. Thank you. Thanks, Rich.
All right. Thank you.
Cheers.
Let's see. Richard Flagg.
Well, I don't have anything to add. I would like to pass along congratulations to Philip and the team with the 8.5 meter dish. You guys are making great progress. It's good to see.
Thank you.
Let's see. Joe Maggie.
I think you might mean me. I'm in Australia. I've already been.
We've had Joe already. Yep. I think SEAC is about the only one.
Yeah, SCA. I'm not sure who that is. C, SEA. Well, I think that's it.
That's probably it then, I think. Yep.
Back to you, Paul.
I think we've finished from
Stephen.
our end. Yeah, we've covered everything. I was just having a look at when the next date might be. So we're so it'll be towards the end of July. 25th, 26th of July, I think, is the next one. Fourth Friday for you, fourth Saturday for us. We had a few glitches earlier in the year, but seems to be working smoothly now. So anybody else want to chip in before we wind up? I think we've covered everybody.
Yeah, Duncan, I'd like to chip in and say my view is that we'll have to do more and more about active RFI suppression inside the signal chains through the systems. I just don't see the situation improving, and there are techniques for doing it, for reducing RFI, if you can get a good facsimile of the RFI source. So, yeah, something to think about if you're beginning to have a lot of trouble. And it's not a trivial job.
All right. One other thing, Paul, for everybody, if you haven't looked at the YouTube channel, we've got the entire Eastern Conference. All of the presentations are up on our Sarah YouTube channel. Very good ones. You guys would enjoy them. Back to you, Paul.
I'm working my way through them. There's a lot to go out there. All right, I think we might wind it up. I think everyone's had a go. Oh, one more. Yep, somebody.
Oh, for me, just something you were talking about earlier, the Muon detector. It's been developed here. I think it's BAA, British Astronomical Society, have a little. If you're aware of it, then all I'm trying to do is make you aware of it. It's a small device, which has been updated and designed, I think, in the last 12 months. And it is not an expensive device, so I don't know if that's of any interest to you.
Yeah, thanks, Joey. I'm aware of that one, and I was going to go along with this commercial one and then see whether they're prepared to come up with just a lower spec one that would be more appropriate for schools. Schools can't afford the full thing. It would have to be sponsored by organizations, but I thought I'd have a look at it and then compare it. So good point. Thanks, Joe. Yes. Okay, Rich, I think we're there. I think.
Well, Stephen Arbogast, you just jumped on. Do you have anything?
Yes, I just wanted to say that I'm using a Dell monitor that doesn't have video. And I've been working with BAA stuff, very cool about correlation. But I don't have it working yet with real antennas, just virtual antennas. So that's all I have from here.
Okay.
Did you hear me?
Craig,
did you hear me?
Oh, we heard you. Thanks.
Yeah, Craig just popped in, but Craig, anything to offer?
No, I'm just happy to be listening in. Carry on.
Right.
Thank you.
Yeah, you can always catch it up on the YouTube version once Rich uploads it. Okay, I think we'll call it a day. Thank you everyone for turning up and contributing. There's so much going on, it fills your head. And see you all next month. I'll send a reminder. Rich will do the same. and away we go. So thank you, everybody.
Thank you
Cheers,
very much.
everyone.
Thanks, guys. Bye bye.
Bye.